Okay, so we know that in order for us to determine the mu maximum, okay, for a graph of x versus t, we need to learn the value of x. Each value of x need to be learned in order to determine the mu maximum by using the equation of ln x2, you learn the x2, and minus ln x1. You have to learn the value of x1 over t2 minus t1. Okay, so if you're using the Excel graph, then from the linear line equation obtained, okay, for the data plotted at the area of the exponential phase, only at the exponential phase, okay? So from the linear line equation, we just take the slope value, okay, from the y equals to mx plus c, the m value, okay, that represents the value of mu max. However, you need to learn the x value first, okay, plot the graph of ln x versus t, then this slope value, okay, will represent the mu max. Right? If you plot x over t, then the slope of the graph is not mu max. Okay, if you're using the Excel, alright. So you need to learn the x value first, all the x value, plot the ln x value, okay, versus t, then the slope of the graph, okay, it will be the value of mu max. Okay. So, in order for us to find the Ks value, the saturation constant value, we know that this saturation constant value is equivalent to the concentration of S at half mu max. Okay. In order to identify the Ks value, first we have to identify the mu value for each of the tabulated data. Okay, to find the mu value, okay, you have to use this equation, mu equals to 1 over x dx dt. So class, from the previous graph here, the x versus t graph, you have to identify the tangent of each of the plot, which represent by dx dt, tangent of each data in graph x versus time, okay, at the exponential phase. Then you times with 1 over x, then you will have the value of mu for each of the data points. Then you identify the mu max value. Okay, after that, find the half mu max, okay, and then later, okay, from the graph, okay, you may able to identify the Ks value, which is equivalent to S at the value of half mu max.